Hello class, today we will talk about VSEPR model. VSEPR model is used to predict the shape, bond angle and polarity of the molecules. So let's first look at the theory and see what does it offer. We have to draw the Lewis dot structure first for any molecule to predict its shape and polarity. So first thing that comes in this theory is the number of electron groups coming from the Lewis dot structure. Lewis dot structure. When you draw Lewis dot structure, you should be able to find how many electron groups are present surrounding the central atom. So let's say I am drawing HCN, the molecule HCN. So carbon should be my central atom because hydrogen cannot be central and nitrogen is more electronegative than carbon. So this is my rough skeleton and how many electrons I have to show here. If you calculate the total number of valence electrons, it should be hydrogen 1, carbon 4, nitrogen 5, total 10 electrons. So we know that hydrogen requires only 2 electrons, but carbon and nitrogen both require 8. So we have to satisfy the terminal ones first with 8 electrons. So 1, 2, 3, 4, 5, 6, and then you have 2 bonds that consist of total 4 electrons, so those are my all 10 electrons. But it is clearly evident that carbon doesn't have octet, so we have to share the lone pairs of nitrogen to make carbon happy with 8 electrons. So now my carbon has 4 bonds, nitrogen has triple bond with the lone pair, and hydrogen, since it requires only 2 electrons, it has a single bond. So this is the correct Lewis dot structure of HCN. If you look at the central atom, it does have 2 electron groups. VSEPR does not distinguish between double, single or triple bond. Everything is considered to be 1 electron density area. That means surrounding the central atom there are 2 electron groups present in this molecule. Now according to the VSEPR theory, if a molecule has 2 electron groups, then the geometry should be linear. So electron groups geometry is linear. Bond angle 180 degree. And the polarity of the molecule depends on the symmetry and other factors that we will discuss later. So next, similarly, if you draw carbon dioxide, the Lewis dot structure of carbon dioxide is like this, and that will be also linear in shape. Bond angle will be 180 degree. Now we come to the 3 electron groups. The example of molecules with 3 electron groups would be BF3, sulfur dioxide, sulfur trioxide, etc. So we will discuss with BF3 first. So we have to draw the Lewis dot structure. BF3, boron 3 plus fluorine 7 times 3, total 24 electrons. If you satisfy the fluorine with 8 electrons, you will see all 24 electrons are consumed, so boron doesn't get anything on the central to satisfy the octet. But you need to know the exceptions to the octet rule that states that boron doesn't require 8 electrons. So that means this is the valid Lewis dot structure. So my electron groups in this molecule should be 1, 2 and 3. So that means 3 electron groups will give me trigonal planar structure. Now the theory says if there is 0 lone pair on the central atom, then your electron group must be same as your molecular shape. So in this case, since there is no lone pair, my electron group geometry should be same as my shape of the molecule, and that is equal to trigonal planar, and the bond angle should be 120 degrees. So shape of the molecule is trigonal planar. Bond angle 120 degrees. Now if we think about sulfur dioxide, draw the Lewis dot structure of sulfur dioxide. Sulfur 6, oxygen 6 times 2, total 18 electrons. Satisfy the terminals with 8. So that means I have 8 plus 8, 16. I have 2 extra. So that will go to the sulfur. So sulfur will have 1 lone pair on the central atom. Now if you review the structure, you will see that sulfur doesn't have octet yet. So that means 1 lone pair should be shared with sulfur to make multiple bonds. So now I bring 1 lone pair from any one of the oxygen atom to form a double bond between sulfur and oxygen. So this is my correct Lewis dot structure. So look at the structure. It has 3 electron density groups. Number 1, number 2 and number 3. So that means it has 3 electron density groups, and that gives trigonal planar electron geometry. Now if it has trigonal planar geometry with 1 lone pair, that means the shape will be different, because lone pair on the central atom determines the ultimate shape. 2 bond pairs and 1 lone pair will produce bent shape. Now if you think about sulfur trioxide in contrast, sulfur trioxide has 6 plus 6 times 3, total 24 electrons. And if you put sulfur as a central atom and then satisfy the terminals with octet, you have used all 24 electrons, but sulfur still doesn't have any 8 electrons. So that means you have to bring any lone pair from one oxygen atom to achieve the octet for sulfur. So this is the correct Lewis dot structure of sulfur trioxide, and again it clearly shows that it has 3 areas of electron density. So that means electron group geometry is trigonal planar, and since the structure doesn't have any lone pair, that means molecular shape is trigonal planar, and the bond angle would be 120 degrees. Now in previous case where you have sulfur dioxide with 1 lone pair, the bond angle should be also 120 degree ideally, but because of the presence of lone pair, bond angle is normally less than 120 degree. But it's okay to write 120 degree as bond angle. Coming back to the next example, let's say we have methane. Methane has 4 electron groups according to the Lewis dot structure. Total 4 plus 4, 8 electrons, and surrounding carbon we have 8 electrons. So that means this is the correct Lewis dot structure of methane, and it shows that since it has 4 electron groups according to the theory, electron group geometry is tetrahedral. One, 2, 3, and 4. Now since it doesn't have any lone pair, that means molecular shape is equal to the electron group geometry. That means it is tetrahedral and bond angle 109 degree. Now if we take ammonia in contrast to methane, in ammonia you have one lone pair on central atom, nitrogen. Ammonia has total 5 plus 3, 8 valence electrons. So 2 extra electrons will be sitting on the nitrogen, and it has also 4 electron groups. So 1, 2, 3, 4. So 4 electron groups means electronic geometry is tetrahedral. And since it got one lone pair, that means shape will be different. That means the shape is called trigonal pyramidal. And the bond angle is still okay to write 109 degree because it is originating from the tetrahedral geometry. Now if we think about water, water has 2 lone pairs surrounding hydrogen. So water also needs 8 electrons in its structure, and 4 electrons are consumed in forming the bonds, so extra 4 electrons are on the oxygen atom as lone pair. So that means how many electron groups does it have? 1, 2, 3, and 4. So 4 electron groups means tetrahedral geometry. But again, according to the theory, the shape is determined by number of lone pair. Now since water got 2 lone pairs, that means the shape will be bent. And the bond angle is 109 degree. So we see that the bent shape is coming from 2 different geometry. If you have trigonal planar electron group geometry, electronic geometry, and 1 lone pair, that means 3 electron groups with 1 lone pair, then the shape is bent. Also, if you have tetrahedral electron group geometry, tetrahedral electronic geometry with 2 lone pairs, then also the shape is bent, but the bond angle is different. When the electronic geometry is trigonal planar and it is a bent shaped, then the bond angle is 120 degree. When the electronic geometry is tetrahedral and it's a bent shaped with 2 lone pairs, then the bond angle is 109 degree. Hope that helps. Thank you.